Hey guys, let's begin. And this video I will show you guys what is Fibonacci and how Fibonacci sequence work in Houdini. Yeah, very quick. And first, what is Fibonacci? Fibonacci is something like this: 1, 1, 2, 3, 5, 8, 13. And so on and so on, which means that each guy of here is HDA of previous two guys. 1 plus 1, 2, 1 plus 2, 3, and 2 plus 4, 3, 5, and so on and so on. What does it really mean? And just imagine a block, a stone, or anything. It's by hitting it, and the energy is inside here, and it broken. And how it broken? And if you broken a huge one, and this huge one, as the energy is already still inside it, you will break it continuously, break into a much smaller one. And as this one still have energy, it will keep breaking, and this guy will keep breaking again. And as over here, this one, this still have energy. It will break. It will break too. It's breaking much smaller than this one, but it's nearly like this one. And the next stage, this one will break in a smaller, and this two will break. Yeah, this two. And this is his children, and this his parent still break. And what does it mean? It means that, let me say, 1, 2, 3, 4. Means that these two guys actually just copy to smallest one, smaller one, and this one it copies itself too. And you say, hey, what is one not copy? Why is it not copy? And no one, because they already have no energy. We suppose that the energy just containing in two stage, and for the next you will guess these three copy here, 1, 2, 3, and these two copy here, 1, 2, 2 plus 3 is 5. This is 3, and this is 2. This is 1. This is 1. And you say, hey, there are 1 here. It's 0. I don't count it. And it looks okay, but you may ask, maybe you will not, but I will ask, why each time it break in 1? it may break in 2, okay? And some will break more. But actually, it is a static science problem. Even if break it in 2, you can consider this 2 is broken in here, right? This is static problem. This is not a problem I wish to consider. So in Houdini, when we break it here, break it down, we can generate this. And if you already see, maybe what? Maybe you should use a stick, right? And if you see the video of Rebelway about One Punch Man, he mentioned it, but he just mentioned it a little while. And unfortunately, I didn't see any placement here in the video mentioning. Here's like this one, and I'll illustrate you. Copy to point here, and be sure in the center. How many times? be more small. Right. How you guys can see this? And you do like this. Use a run. Use run. Custom run. Right. And just this. Come on. Just this. Yeah. What does it mean? It means that there is more small popularity in a huge one, and more points, more amount of points, it will be a much smaller one, and it is this one. So many points, so many guys is very tiny, and a huge guy, it will be very small. It will be very little, just one, and just one here. So, and you can imagine we are not do this all the way. Imagine another one block, it will be like this. And small, another block like this. So for illusion, in Houdini, you can just use the probability to do this, right? But unfortunately, I didn't see Rebelway mentioned in other video, and I don't know how they do it. And if I want to tweet this one, it made me crazy. So I did one. No. Yes. Actually, I did many notes to do this. And over here, you see I do this Fibonacci number and Fibonacci number. Can be 1, 2, 3, 5. Maybe more. And you can see just 1 of 1, right? 1 of 1, 1 of 1, 1, 2, 2 of 2, 1, 2, 3, 3 of 3, 1, 2, 3, 4, 5, 5 of 5. What does it mean? It means that's good. Look at this. 1 of 1, 1 of 1, 1, 2, 2 of 2, 1, 2, 3, and 5 means. So what should we use this? You can see that I generalize a p-scale here, and we're not here. For electric purpose, just use 0.5. Each stage, it will be a half. Means that the first stage, it will be the p-scale will be 1. Okay. And the second stage, it will be a half. And the next stage, it will be a half and a half, and so on and so on and so on. Half and half and half. And over here I create a controller for it. So let's see what will happen. We can use this guy and this thing. And see the first one here, the 0.0. The first one is huge. And the second one is half. And the next two is half of half. It's 0.25. And next two, and then next to 3 is 0.125. It's interesting, right? It's interesting anyway to see. And I use a random way too. Random way. Maybe use normalize. Already normalize. Huge. Don't be so. So the p-scale will distribute all the way, no matter how. And maybe you can use a Greek. Funny. Yeah. And what is it used for? What is it used for? We should know that we are talking about the brake, the stone brake. So we do a brainstorming the boss, and we do one nice and not just. How? And oh, so many points. I don't want it. Will you please? Okay. Like this. I want to apply the P scale in H1. In fact, you what about apply after? You have many ways to do this. You have many ways to do this, right? You will see that here we have a point over here. What I do it is just take here and we store the P scale in here, and it will be nice. It will do nothing, but you can do that. Yeah. We replace it by P scale, and you will see. Maybe. Hey. Come on. Get more fun. Come on. It's very, very tiny. That's not enough. And then we should all use order. We use order. We have P scale, we relax. Relax is this 3D space. Let me see. We just look at this. Yeah. The zero, because you have two huge P scale. This radius, it goes up, relax it. And so on and so on. And the last one, they didn't. And it was a magic. And now, it's not that way. Okay, match side. And this time will be much better. Right. Look at this. The Explorer, what is this? Yes, this one is huge, and this guy is very small. It's still not enough, right? You can check. And I will show you how I create this in a more. A more sense in here. And maybe we don't need this one. It can be smaller. And next time, the next P scale will be much smaller, right? 0.261 times 0.26, 0.26 times this, like this. Yeah. And we need to have a shift here. Okay, the render. See, the render thing treat as a shit. I don't know why, I do. Yes. So, let's come here. Just pay. Hello. Let's do a copy. Copy and transfer. And we just need one. Smaller one. Huge. Please transfer it. And you guys may already know what I want to do. And copy again. I don't do this. And copy it. Oh, I find I didn't it. I just need to copy the point. Yeah, you already have the point here. I don't know. Copy the point. And with the copy the point, I put here. Put a P scale in here. Right. One is small, one is huge. And what should we do? That's what we do. We bring enough. Apply this. Make this to be data. Come on. My motion is a full guy. Come on. Oh, come on. Ah, damn. It scared me. So fine. Yeah, and this time, is it? Not exactly. Not exactly. But you can do this. You can do it many ways. Anyway. And you guys should already understand what I mean. There's many ways to do this. There's many ways to use this. You didn't really just need to be in P-scale. You can use it in color and anything else. And I'll show you. Let me see if still anything funny. Random mass iteration. Aha. The order. The shape. I think I already mentioned many much. And here, our P scale. If I don't use our P scale, we just have P scale. Right? And this two is actually the same. It depends on you. Alright, and I will mention another very nice in sizes and materials, battery. I don't remember which one. This one. Oh no, not this one. Not this one. So, yeah. It's very slow. So, and this is actually belongs to the point inside. You can see here, concrete, glass, wood, and another thing I don't want to use it. Concrete, here, and over here we have the dripping and primary. Primary I will delete because threshold in here. Over here, a scattering. And from here, let me see what it is. What actually it is. Here, now here. Much. This. What this it is? Oh here. Oh here. It's not. It is fun. Look at this. It is fun. Right. If it's after. Just need before. Oh, here is the geometry. And over here, Yeah, this one. Come on. Why is just I don't know why this river already appear. Yeah. Yeah. And over here we can do something between. Yeah. Yes. We bring a piece again here. Right. And do the rest. And maybe we should see more better. That's by the piece here, right? And you then use random use order, right? We should match that back to here, and maybe you can even transfer, right? And we look at this. Oh. Nice. Why this mesh that? Oh, this okay. Sure. Because primarily inside, this is our point. It's very tiny. This is our point, but it's very tiny, and you can transfer it. Actually, it's scale. Hey, make smaller. It do affect it all, right? And you can just do it. And for mine, and you can see another one. H1 have this one. Over here, chip. Chipping means the little break in here. You have this one too. I do this. Come on. This part is very tiny, just inside here. You can do this in here too. And glass, you can do the glass too. Over here, the glass pressure. Yeah, chipping and regulate. Come on. And over here, you have this. It's very handy. I see I ready to more. Yeah, over here. Then this is the glasses. And it somehow make this issue. But I don't know. I don't know why. And this is why I didn't do this material fracture, RBD material fracture into HDA, because it always makes an issue if you repeat this one, like walk one, maybe you can fix it. Oh yeah, it's no. Let me see. Oh no, it didn't fix it. It should be a circle. Yeah, it should be a circle, but over here it just form one. If you see this one, one refresh. This 4 point differential. We should no do this. Yeah, this 4 point, and suddenly you have a line in here, a line here. This is point, and 1, and 2, and 3, and 4, and this 4 point that the cut. Okay. You can manipulate this proper in here. I know it. Let me see. The glass have the chip too in the sun. And what about the wood? And the wood is somehow boring. Yeah, it's not boring. It has a bone fracture here. Oh no, I don't mean this. And maybe you picture this. What? Do it. Just do it. Come on. 1, 2, 3. That's why. If you didn't do this, another card, it's very boring. It just 1, 2, 3. It just have this sound like meat or something. You know that it break it down here. It break up down here, and then it just noise. It just noise it. Remesh and noise it. It's just simple. I don't like this. But what really interesting is this card. But at the time I see how this card do, and I'm not interested now. This guy just in normal. No, it's just your noise. Just your noise. It noise this face point position, and then use the boolean. Let me see. Show him. It's over here. Right. Okay, it's jitter. And this is before. This I don't know how to. And it's after. Boom. Before, after. And over here, it's the position. You just use the position and plus this normal. Normal is over here. Oh, and now. You should know it. With the n equals y cannot. Yes, you can. Oh, why not? I don't know why. Yes, you can. And again, the normal is this cutter direction, which means over here, this direction. And you use the shift disk. So this shift disk is picking from the max shift, negative max shift to the max shift, and this max shift is from over here. The length is small. Okay, can be small. Alright, very small. Oh. And next one is this CH cast space. This next shift. Oh, I see. Over here. And next one is just render it. Yeah, you just use a render. And actually, you didn't need to render, because a render is very unique. Like over here, you see. If you render, it's very unique. The smallest one, for example, the smallest one have 10, the biggest one have 10 too. And we can rewrite. Yes, we can rewrite. And here we get the P scale. I use P scale to drive the random. And how? Let me see how. P P scale, try it, max shift, Jordan, maximum shift here, and maybe here, and just try. I'm not very sure. Next shift. P scale. I mean, just make that. Try. Oh, it's very small. After P scale. You should understand what it is. It's not zero. You should understand what they mean. Please. Oh, I see. Oh, I see. You should do it here. So maybe here. Just a little. Try. Can we just here? Oh, sounds like attention. Okay. This one should be okay, right? And now let's try another P scale. And if you want to completely join the P scale and don't want to rhythm, let it no max. I'll try. I didn't try it. I'll try. It just fine scale. Just one survey. Wow, face it. And you see, this is driven not the P scale, not the random, but Fibonacci. And this is much better than before. I don't remember what before. Try. And this is before. And this is hormone. And if you really write this, I have no idea. And let me see, if you always do this, it will be terrible. So actually I do Acuumulate here. Right here. And come here and do some little change here. Use this card. I don't remember how to do this. Let me see. How we do naturally. Let me see how to do this. And you should understand what I mean. You should understand what I mean. Concretes, fractal, point, okay, point, I did switch here. Switch concrete, if I switch here, switch here, it will just use this Acuumulate. This Acuumulate is linking to outside. I can do anything. Yeah, so we use a more. Just copy it here. I try. I remember this is not working. It's not working, it's not because of this. Maybe I'll show you. Maybe I need to show you. Maybe I'll show you. And before this, I will see if there is still anything in here. It's in random and auto, and just one thing. If you turn it to the order, it means in 1, 2, 3, 5, and larger, and if it will higher and higher, 500, if you get more, it looks okay, right? But if you use a box and I just link it here, it will crash. I will not do it here because there is too many points here. It's not so many. No, you don't have many. It's 1,000. And you may be more. It will be 100,000. 0.01. 1 minute. Yeah. Why? Because this length is 1, and separated is 0.01. So in this direction has 100, and this is 100, and this is 100. It's 1 million. And as it goes 1 million, it will just out of the ball, and it will make any crash. Houdini will angry. Let's see. Can I show this one? Yeah, this is before. Double temperature. Oh, here. You just Acuumulate here. Come on. Come to here. This is class 1. Where is class? I don't care. So this is I do it. DNA is always okay. This point before, I do a Fibonacci here, P scale, where's P scale, and part length, much size, back transfer, and then use no in here, and this no we try back to L, and then going to go back. And actually I don't think this is a good idea. And what the problem is, it cannot save in HDA. At the time I saved this in HDA and it got angry. I don't know why. Hey, look, it got angry. I don't know why. It means that the selection summit has reference to outside to a summit. I don't know why. No matter how, it just I try anyway. And oh boom, no. I think this I already mentioned enough. And one of the Fibonacci is that you may know that this is not just happen in different places. It just does not is the problem. It can happen in many ways. For the ocean or color and the texture, you may see the texture is still like this one. The texture is skin or the color or many things. They act as a Fibonacci. This is the physical color. It's a science color. And it's not always good to just use random, just directly use random or directly use noise. You should do something to it. And Fibonacci here, I do this just for one click. And this is for this video. The next video I will mention another 3. It's ARMA. What that is accumulate random moving average. And see you next time. Goodbye.